Okay, let's look at the Lila problem. Okay, we're thinking about slope and y-intercept, okay, or rate of change and initial value, okay, same thing, as we complete this slide. Okay, what I would do is look at the part that's given first. Okay, the graph is given. So it's showing that at 0 minutes, Lila has walked 0.5 miles, a half a mile. After 10 minutes, Lila has walked 1 mile. After 20 minutes, Lila has walked 1.5. Okay, after 30 minutes, 2 miles. Okay, so we want to fill out the entire slide using this graph, the information in this graph. Okay, what I would do, because there's so many different ways, so many different orders you could do it, is I would try to think about the slope and the y-intercept from the graph. Okay, I'm going to look at the y-intercept. The y-intercept would be how many miles after 0 minutes. Okay, that'd be a half a mile after 0 minutes, because this is the y-axis. Okay, this is where the graph is crossing the y-axis, so that's the y-intercept or the initial amount. Okay, so I'm going to go ahead and start off with the sentence here at the top. Lila started off the week having walked 0.5 miles. Okay, and then I'm going to look at this, try to answer the other part of the sentence while I'm up there. Okay, and then she will walk blank miles every blank minutes. Okay, different ways you can answer that. I put the snip and sketch up here so we can look at it better. Okay, we could go from one point to another. You can choose any 2 points you want to. Okay, you could use 2 points that are close together, and you could think rise over run. So you could think of it as going up a half a mile as she goes over 10 minutes. Okay, so you could have worded that as up half a mile every 10 minutes. Okay, there's nothing wrong with that. I don't like that one half. I just don't like it. So what I'm going to do, I'm going to pick 2 points that are farther apart, maybe like these two. So if I'm going to think slope from these 2 points, I'm going to think of it as going up an entire mile. Okay, see how I'm going up 2 halves? I'm going from mile 1 to mile 2. So I'm going up 1 mile, and then I'm going over, okay, let's see, I'm going from 10 to 30. I'm going over 20. So I'm going to think of it as going up 1 mile and over 20 minutes. So she's increasing 1 mile every 20 minutes. But again, I could put 1 mile for every 20 minutes, or I could put a half a mile for every 10 minutes. Okay, they're both okay. Okay, now I'm going to go ahead and I guess work on the data table. At 0 minutes, we already said that she's gone 0.5 miles. And then after 10 minutes, I'm just going to look at the graph. After 10 minutes, she's gone 1 mile. After 20 minutes, she's gone 1.5. See how she's going up a half every 10? I'm just going to follow the pattern. It's going to go up 2, oops, and then 2.5. Hey, I already know the initial value because that was the y-intercept. That was the half of a mile. Okay, my rate of change is the slope. Okay, we talked about that a minute ago. You could think of it as up a half over 10. You could write it that way, 0.5 over 10. I think it looks a little bit better if you think of it as up 1 over 20. See, while you have here 0.5 over 10, you have a decimal within a fraction. That's called a complex fraction. They're just kind of messy. It's okay. It's legal, but it looks a little bit better to write it as 1 over 20. Okay, my equation, y equals, the slope goes first after the equal sign. That'd be 1/20th or 0.5 over 10. Okay, then the x, then the plus, and then the initial value of 0.5. Got a lot of pluses in there. Okay. How many miles has Lila walked after 70 minutes? Okay, so 70 minutes. You could use the formula, the equation. You could put 70 minutes in for x. Okay, you could put 70 in for x because x is minutes. Figure out y because y is miles. So you could take 1 over 20 times 70 and then add 0.5. And that'll give you the answer. But what I'm going to do, since this is almost easier for me to just use the patterns. If I'm gone 30 minutes, 2 miles, 40 minutes, 2.5. That means after 50, I've gone 3. That means after 60, I've gone 3.5. And that means after 70, she's gone 4 miles. See, I'm just following the pattern. I'm continuing to go up 10 on the x side, and I'm continuing to go up a half on the y side. So it'd be 4. Okay, but again, there's many different ways you can answer these questions. And different ways to come up with them, I should say. So how many miles has Lila walked after 70 minutes? Okay, that'd be 4 miles. We'll look at other ways to do this in class too, but that's probably the way I would attack this problem. Okay, let me know if you have any questions.